So okay, guys, now you know that about this thing is a gradient and this one vertical shift and also a y-intersect where x is equal to 0. Yeah, so here you can just screenshot and do some notes, yeah, but for this video it is based on what? On gradient. Let's study about the gradient. So a gradient actually it is a slope. Gradient. This thing is what we call slope. Do you see? And like a slope, you can imagine as in a hill or mountain or steps or what. Yeah, like let's say here. So a gradient, guys, a gradient, we usually use M to represent gradient. That's why in most time when you get the equation for a straight line, you'll get mx plus or minus c, which is that m represent what? Your gradient. But the reason why I just turn that equation into this something like x plus minus b, it's because I want to do like a comparison between these two equations. Yeah, I want you to tell you that something which is in this position, it will be a gradient, and something in that position, it's a vertical shift or the y-intersect. Do you understand? Yeah. So don't mind the alphabet that they use. What you should understand like the equation, yeah, the format, the way this equation it's been written. Do you see that here it's x here and there it's y, even here it's y, but here it's x squared, and this thing is parabola, this thing it's a straight line. Do you see? Yeah. So now when I'm talking about a gradient can be expressed within this equation, changing y divided by changing x. And now when I'm talking about a change, I'm talking about the different in y values. So the different in y values, it's minus y2 and minus by 1. And difference in x values, it will be x2 minus by x1. And this thing now, when I substitute it there, and this one substituted there, this equation, it becomes something like minus pi over changing x minus by changing y. Oh, yeah. So what I want you to recognize, this is the equation that we'll be using to get a gradient. And this equation, you don't just apply anywhere. You only apply in a straight line, which is in this form, or in this form, or in that form, or in this form. Do you see? Yeah. And here, say here it's your head, this one is your right hand side, and this one is your left hand side. Meaning now your gradient here it's negative, gradient here it's positive, gradient here it's equal to 0. What about the gradient here? This thing, take it as in like it is the system of your body. It is your body, all this part. This one is your head, right hand side, left hand side, and now it's your body, this one. And now your body, now it has a gradient which is undefined. Yeah. So this thing it's undefined, guys. So meaning if you are using this equation for this thing, you'll get 0. But if you are using for here, you'll get undefined. If you are using this one, you'll get a positive answer, you'll get a negative answer. Do you see? Yeah. So now a gradient, guys, just imagine as in I have a slope, a slope something like this. Do you see the slope? Yeah. You man, I have a hill. A gradient, let me tell you something. A gradient, it is the same as the what? As the slope. And this one, it is the hill. Yeah. And this hill, as the time goes, it become like this hill become like this. Then as the time goes, this hill will find out now it becomes something like that. And now what will be causing this hill to change the shape? It will be something like rain. If there is more rain, if there is more rain, and all the stuff will just erode, go down, do you see? So like what I want you to notice is that when I'm talking about a gradient, I'm talking about a slope. A slope is this part, is this one, do you see? And this thing, it is what we call what? A increasing slope or gradient. So this one, it's what we call an increasing gradient here. It's when like the what, do you see the shape? It's when the gradient here is positive, you see. And now this one, it's what we call a what? A decreasing slope, this one. So let me write it down. This thing, it is the decreasing gradient. So I got the increasing gradient and the decreasing gradient. It's where it is negative. Do you see this thing? It is that one. Do you see? So now as the time goes, this thing, it become more gentle, and now it became more jungle. Do you see? So what I want to tell you is that like a straight line can be like this way, and it can be just become more jungle, and become more jungle. Do you see? Or it can be just going up like that, become more steep and more steep. Do you see? So let me just go to Cartesian plane now so that you can understand all what I'm trying to say. So here you can just take a screenshot, do your own notes now. So here's like a Cartesian plane now. So this one is my Cartesian plane. It's x and y values. So it will be good, guys, if you can just do like a research about a gradient so that you can imagine what I'm talking about. But what is a gradient actually? Try to understand deep. But what I will be teaching here is to show you how to calculate gradient and show you how to apply it. So let's say I got this graph. So this graph, guys, it's what we call a matter function, this one. So a matter function, it is the original function. So this one, it is the original function for a straight line. Do you understand? And this equation, actually, it is coming from this equation of mx plus or minus c. And now this, and now our y-intercept, it's equal to 0, meaning that the equation become x plus minus 0 is equal to y. Do you see? And now this thing, 0 will just disappear, and then the equation will become like that, meaning now this equation will just become like y is equal to mx. So what I want you to recognize is that the gradient of this line, the gradient of all this line, this one, it is invisible one there. It is invisible one. And as that gradient, I increase it to 2, or I increase it to 4, or let's say to bigger number, and 19 or 23 or 51. So as I increase this gradient here, so as I increase that gradient, you will see that the line will become like this way now, come like that. But you'll be using a ruler, guys, so it will become like this. As I increase the gradient, this thing it become like that. So here I'm increasing the gradient. what do you notice here when I'm increasing the gradient? As I increase the gradient, I'm getting close to the y values. Do you see that? As I increase the gradient, I'm getting close to the y values. And this one, guys, is just a positive gradient. Yeah. As I increase a positive gradient, I'm getting close to the what? To the y values. As I increase a positive gradient. So now, if we decrease this gradient, what will happen? Obvious, now you can even guess it, this one. So let's say now I'm decreasing that into 0, 0,8 and 0,7, 0,5, 0,3 and 0,1. Yeah. So as okay, so this thing, it's x, 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 x. So what you should notice is that here, as I decrease the gradient, what will happen to my line? Do you see what will happen to my line? As I decrease the gradient, my line is getting close to the x values now. So this thing, we'll be using a ruler, guys, to draw all this stuff. Yeah. So as I decrease the gradient, I'm getting close to the what? To the x values. So as I decrease them, yeah. So I hope, guys, you can see all my work. Yeah, even though it's not accurate, but try to understand. Yeah. So here, as I increase the gradient, I'm getting close to the y values. But as I decrease the gradient, I'm getting close to the what? To the x values. Do you see? And this one is just a negative gradient. Yeah. So as I increase a positive gradient, I'm getting close to the what? To the y values. And as I decrease the positive gradient, I'm getting close to the x values. So what I just show you now, it is for a what? For a straight line. Even similarly to a what? To a parabola. So let's say this parabola, we are doing it here. So this parabola, we are doing it from here. So this one, it is the matter function for what? For a parabola, which is, it's represented by this equation, y is equal to x2. Yeah. And now you can see your gradient, it is invisible one. Do you see invisible one? Yeah. So now let's say now I'm increasing this gradient into 2, 2, and 3. And now let's say it's 5 and 6. Yeah. You will see as the way I increase this gradient, what will happen. Yeah. So as I increase this gradient, this thing is getting close to the y values. As I increase the gradient, this thing is getting close to the y values. Do you see what is happening? It's getting close to the y values. Yeah. So as I increase the gradient, my graph getting close to the y values. Remember, guys, these one are the y values. These are the y and these one are the x. So as I increase the gradient, the graph getting close to the y values. Getting close to the y values, getting close to the y values. When I increase the gradient. Now let's say now I'm decreasing this gradient. So here, as I decrease this gradient, it will become like this. It will become like that. It will become like that. Do you see most what is happening here? So here I just decrease the gradient 0,8 and here 0,5, 0,2 and 0,1. Okay. So x squared, x squared, x squared and x squared. Yeah. So do you see that, guys? When I decrease a gradient, this positive gradient, I'm getting close to the what? To the x values. Yeah. As I decrease this gradient, I'm getting close to the x values. Yeah. So as I decrease this gradient, I'm getting close to the x values. And that one, it is the matter function of a positive gradient. So this one is just a matter function for a positive gradient. Then as I increase the gradient, I'm getting close to the y values. But as I decrease, I'm getting close to the x values. Do you see? Yeah. Yeah. So now you can just take this thing that as I increase a positive gradient, I'm getting close to y values, y axis. As I increase the gradient, I'm getting close to y axis. But as I decrease a positive gradient, I'm getting close to x axis. Do you see? Yeah. So now I'm talking about a positive gradient, guys. When I'm going to a negative gradient, things will be kind of different and will be kind of different, and they will try to be tricky. But don't panic, because you got me, Yeah. There's no way that you cannot pass. If you try to listen and try to understand, and also you are curious. So I hope, guys, you did understand that as I increase the gradient, I'm getting close to the x values. As I decrease the gradient, I'm getting close to the y values. So you can just screenshot this thing and do your own notes. So try to see the difference between a positive gradient and a negative gradient, and check the way they behave. So here I'm given this thing, which I can see the gradient is equal to what? Invisible one. You see, it's invisible one. And I told you that as I increase that gradient, as I increase it now to say, let's say maybe it's 6, let's say it's 13, 24. So, and here I'm still got that x. So what I want you to recognize is that as I increase the gradient, I'm getting close to the what? To the y values. As I increase the gradient. Yeah. So do you see that as I increase a positive gradient, I'm approaching the what? The y values. I'm approaching the y values. As I increase the positive gradient, I'm approaching the y values. As you can see, guys, here, that I'm approaching the y values. Yeah. So then I'm approaching the y values as I increase. So even here, if I want to draw the graph here, the graph which will be there, it will have the gradient which is 0.5, or let's put 8. Yeah. 0, yeah. So this thing, it cannot be less than 5. Yeah. It cannot be less than 1, and also it cannot be bigger than 1. It should be between them. Do you understand? Yeah. Because this graph, its equation, this equation, its graph is this one. You see this graph? And now here I got this one. I got this one here. I got this one. And now the moment I draw this graph, it must be between 2 and 1. X. Yeah, it must be between there. That's why I decided to put 1,8 x. Yeah. So now let's say now we decrease this gradient. So if I'm decreasing it, it will become something like this. Something like that. As you can see that I'm trying to get close to the x values. Yeah. So here if I decrease 1 to 0,8, yeah, and say now it's 0,45 or 0,25, 0,1, 0,11. So here I just decrease my gradient. Do you see? As I decrease the gradient, I'm getting close to the what? To the x-axis. But now when it goes to a negative gradient, things, they become different now. So now here, as I decrease the gradient from -1 to -2 and to -3, -4. So as I decrease the gradient, here I still got x, and here I got x. So this thing, as I decrease, it will go like that. As I decrease, it will go like that. As I decrease, it will go like that. Yeah. So and please be aware, guys, my graph is not that accurate. Yeah. But if you can try to draw it accurate, you will find it. But this one, as I decrease, as now I decrease a negative gradient, I will approach the what? The y-axis. But now as I increase this thing, it will approach the x-axis. Yeah. This thing, it will be the vice versa of this one. Because here, if it is positive gradient and we decrease it, we can see that it approached the x-axis. But as we increase it, it will approach the y-axis. Do you see? So now let me show you if now we increase this thing, then from -1, let's say now we increase it to -0,5, 0,25, -0,15. So this one is my x. So you will find out as now I increase the gradient, this line will become like that. So it will become like this. Yeah. So here, as I increase a negative gradient, I'm getting close to the what? To the x values. Do you see? But as I decrease a negative gradient, I'm approaching the what? The y value. I'm getting close to the y values. So this thing, it is just the vice versa of that one. Do you see? Yeah. Here, as I decrease a positive gradient, I'm getting close to the x-axis. But here, as I decrease a negative gradient, I'm getting close to the y values. Do you see? Yeah. So even in parabola, it is same situation. So check something in parabola. So here, let's say now we are increasing the gradient, it will become like this. If we increase this gradient, it will become like this. This one, it is the positive gradient. So now we have increased it to 2x squared, say 4x squared, 16x squared, and say 25x squared. Do you see? Yeah. So here I just increase the gradient. But if you can check from here, when I increase it from -1, I will increase it to 0,8, -0,5, to 0,25, -0,15, 15 ne. So here I'm increasing this gradient ne. So here what you will notice, as I increase a negative gradient, this thing, it will just approach the x values. It means that it will get close to the x values. Yeah. So now I'm getting close, as you can see them. I'm getting close. Yeah. So this one will just say it's minus what? 0.12x squared. Do you see my study? Yeah. So as I increase a positive gradient, I'm approaching the y values when I increase a positive gradient. But as I increase a negative gradient, I'm approaching the x values. Do you see that? This thing, it is the vice versa. As I increase a positive gradient, I'm approaching the x or at the y value, the y-axis. But here, as I increase a negative gradient, I'm approaching the what? The x-axis. Here I'm approaching the x-axis as I increase a negative gradient. And here, as I increase a positive gradient, I'm approaching the what? The y-axis. So now check something. If here I'm decreasing this gradient, something like this. Here I'm decreasing now. I'm decreasing the gradient. Here I'm just decreasing the gradient. As you can see, maybe that gradient from 1 to, then let's say decrease to 8, okay, 0.88 squared, or it becomes 0.5x squared, or it becomes 0.25, or it becomes like 1/5 x squared. So I just hope guys you can see this thing. Yeah, I hope you can see that. Here I'm decreasing a gradient, a positive gradient. And as I'm decreasing a positive gradient, I'm approaching the x values. Do you see? Yeah. So what about for a negative gradient? For a negative gradient, as you decrease, you will be approaching the y values. As you decrease here, you're approaching the y values. So this thing actually start there. Yeah, I made a mistake, but I just want to show you easy way. Yeah. So as here I'm decreasing the gradient, this thing, it will approach the y value. So you should know now, as I decrease the negative gradient, I'm approaching the y value. But as I decrease a positive gradient, I'm approaching the x axis. Do you see? Yeah. 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 So I think guys you did understand. You can just try to screenshot and do your own notes. Thank you.